In the grand theater of the cosmos, humanity is a newcomer, an intelligent flicker barely visible against the vast darkness of time. Yet in only a few centuries, we've gone from staring at the stars in wonder to realizing that each one of those distant lights may host entire worlds of its own. This revelation has changed not only astronomy, but the way we think about ourselves. Because hidden in that question, are we alone, is something much larger. What does it mean to exist at all? For thousands of years, the night sky belonged to myth. To the Sumerians, stars were gods. To the Greeks, they were campfires of heroes. Even as the first telescopes turned skyward in the 17th century, the stars seemed eternal and unreachable. Then came a revolution. When Galileo discovered the moons of Jupiter in 1610, he shattered humanity's sense of cosmic isolation. For the first time, we saw worlds orbiting another world. The heavens were not immutable. They were dynamic, alive. But even then, the idea of planets around other stars, exoplanets, was little more than a dream. It wasn't until the late 20th century that technology finally caught up with imagination. In 1992, radio astronomers Alexander Wolszczan and Dale Frail made an astonishing discovery. Using the Arecibo telescope in Puerto Rico, they found tiny variations in the timing of radio pulses from a dead star, a pulsar, called PSR B11257 plus 112. Those variations revealed two planets orbiting the pulsar. These were the first confirmed exoplanets in history. They were nothing like Earth, blasted worlds circling the corpse of a supernova, but they proved that planets beyond the solar system were real. Just 3 years later, in 1995, Swiss astronomers Michel Mayor and Didier Queloz announced another breakthrough, the discovery of 51 Pegasi b, a giant planet orbiting a star similar to our Sun. The planet was strange, a hot Jupiter, orbiting extremely close to its star, completing a full revolution in just 4 days. This upended everything scientists thought they knew about how solar systems form. The cosmos, it seemed, was far more creative than we'd ever imagined. By the turn of the millennium, the hunt for exoplanets had become one of astronomy's most thrilling pursuits. Instead of looking directly at these faint worlds, scientists studied the light from their stars. When a planet passed in front of its star, it caused a minuscule dimming, like the flicker of a candle behind a moth's wing. Detecting that flicker required instruments of unimaginable precision. That's why NASA launched Kepler in 2009, a space telescope designed to watch over 150,000 stars continuously, searching for these tiny periodic dips in brightness. Over 9 years, Kepler transformed human understanding. It found thousands of exoplanets, from scorching gas giants to small rocky worlds that might have oceans and clouds. Kepler's data revealed a stunning truth. Planets are not rare. They are everywhere. Almost every star in the Milky Way likely hosts at least one. Statistically, there could be more planets than stars in our galaxy, over 100 billion. And among them, millions could be similar to Earth in size and temperature. Somewhere out there, perhaps a planet orbits a yellow sun beneath blue skies, with wind over grass, water reflecting alien clouds, and creatures staring up at their own night sky wondering the same thing we do. In 2018, as Kepler's mission came to an end, its successor took the stage, TESS, the Transiting Exoplanet Survey Satellite. Unlike Kepler, which stared at one patch of sky, TESS scans almost the entire celestial sphere, seeking nearby worlds that future telescopes could study in detail. Within its first years, TESS discovered hundreds of exoplanets, including TOI 700d, an Earth-sized world in the habitable zone of its star just 100 light-years away. Another, TOI 700e, announced in 2024, deepened the excitement. These discoveries showed that potentially life-supporting worlds might lie just beyond our cosmic doorstep. But detecting a planet is only the first step. To know if it could host life, we need to study its atmosphere, the gases that shroud its surface, absorbing and reflecting starlight in subtle ways. For that, humanity built its most ambitious observatory, the James Webb Space Telescope. Launched on Christmas Day 2021, Webb unfolded a golden mirror the size of a tennis court and took its position 1,000,000 miles from Earth. Its infrared instruments allow it to detect the faintest heat signatures from distant worlds, light that has traveled for centuries. Webb's mission is to look back in time, to study the first galaxies and stars, but it is also our most powerful tool for searching for life. In September 2023, Webb's instruments detected something astonishing. When analyzing light from the exoplanet K2-18b, a sub-Neptune 120 light-years away, scientists found traces of methane, carbon dioxide, and even possible signs of dimethyl sulfide, a molecule produced on Earth by living organisms. The team, led by Niku Madhusudan from the University of Cambridge, cautioned against sensationalism. "We cannot yet confirm life," he said, "but the data are intriguing." For the first time, however, we had a real candidate for a living world. That same year, Webb observed WASP-39b, detecting sulfur dioxide in its atmosphere, the first direct evidence of photochemical reactions beyond our solar system. These reactions are driven by light, just as sunlight creates ozone on Earth. Webb was not only detecting planets, it was beginning to read their chemistry, like decoding the DNA of distant worlds. By 2025, humanity stood on the brink of a new era. Over 5,000 exoplanets had been confirmed, with thousands more candidates awaiting verification. New missions were being prepared. ESA's Plato, planetary transits and oscillations of stars, NASA's Nancy Grace Roman Space Telescope, and LUVOIR, a conceptual observatory that could one day directly image Earth-like planets and detect the spectral fingerprints of life. But amid this explosion of discovery, a deeper question began to emerge. What happens when we finally find proof of life beyond Earth? Would it unite us or divide us further? The search for life is no longer fringe science. NASA's astrobiology program, the SETI Institute, and international collaborations like Breakthrough Listen now systematically search for biosignatures and technosignatures, clues that something out there might be alive or even intelligent. A biosignature could be a mix of gases like oxygen and methane existing together in a planet's atmosphere, an impossible combination without biology to sustain it. A technosignature could be a narrow-band radio signal, a laser pulse, or even the infrared glow of a civilization's energy use. In 2024, the Allen Telescope Array and FAST, the world's largest radio dish in China, conducted deep surveys of nearby exoplanet systems, focusing on stars known to host Earth-sized planets. No confirmed signal was found, but in science, silence is never failure. It is data. Each unanswered message defines the limits of where we must search next. Meanwhile, within the solar system itself, discoveries kept pushing the boundaries of what life could mean. Beneath the icy crust of Jupiter's moon, Europa lies a global ocean with more water than all of Earth's combined. Plumes of vapor, detected by the Hubble Space Telescope and confirmed by the Juno mission, spray into space. Chemical invitations for exploration. Saturn's moon Enceladus does the same, ejecting jets of organic-rich material from cracks near its south pole. In 2025, NASA's Europa Clipper spacecraft prepared to launch, promising to map the moon's surface and sniff its vapor plumes for molecules that might hint at biology. If life exists anywhere beyond Earth, said planetary scientist Robert Pappalardo, Europa is the place we'll find it first. Even Mars, long thought barren, keeps surprising us. The Perseverance rover, still exploring Jezero Crater in 2025, continues drilling and caching samples of sediment that once formed in an ancient lake. NASA and ESA plan to bring those samples back to Earth by 2033. If fossilized microbes lie within, it would mean that life began at least twice in one solar system, making it virtually certain that it thrives elsewhere too. But the question of intelligent life, civilizations capable of thought, art, and curiosity remains a haunting silence. In the 1960s, physicist Enrico Fermi famously asked, "Where is everybody?" The Milky Way is old enough and vast enough that if intelligent species had arisen frequently, we might expect to see signs of them: radio transmissions, star-scale engineering, or probes. Yet we hear nothing. This is the Fermi Paradox, the great contradiction between probability and observation. Some believe intelligent life is rare, that Earth might be an anomaly. Others suggest that advanced civilizations might destroy themselves before achieving interstellar travel, a cosmic reflection of our own fears. Still others propose that they are out there, but we're looking in the wrong way, or perhaps they choose not to interfere. In 2025, as artificial intelligence and quantum computing reshape our civilization, that paradox feels personal. Our own species stands at a crossroads, expanding outward into space even as we grapple with problems on our homeworld: climate change, inequality, conflict. The stars remind us that survival and exploration are not separate struggles, they are the same. As Carl Sagan once wrote, "The cosmos is within us. We are made of star stuff. To look outward is to understand ourselves." The Vera Rubin Observatory, beginning its full sky survey in late 2025, is expected to capture billions of new celestial objects, including interstellar visitors like Oumuamua and 3I Atlas, which have already challenged our understanding of how the universe works. Each of these discoveries reminds us that the cosmos is active, dynamic, and full of mysteries still beyond our reach. As data pours in from space telescopes, AI systems are now analyzing it faster than humans ever could. NASA's ExoMiner and ExoAI projects use neural networks trained on Kepler data to identify new planets automatically, confirming hundreds that human teams missed. Machines now see the universe for us, translating starlight into meaning. This partnership between human curiosity and machine precision is building a future where discovery is constant, where we may one day predict, rather than merely detect, worlds capable of life. And yet, for all our technological triumphs, one thing remains deeply human: the feeling of wonder. Every new planet, every glimmer of light, brings back the same question that drove our ancestors to light fires beneath the stars. Are we unique? Imagine the day when the answer finally comes. When a telescope, perhaps Webb's successor, detects a thin band of oxygen and methane in the spectrum of an Earth-sized world. When the data, verified and peer-reviewed, confirms what we've suspected all along: we are not alone. What happens next? Do religions rewrite themselves? Do nations unite or compete? Do we reach out or retreat in fear? Sociologists, philosophers, and scientists have begun to prepare for that day. In 2024, NASA quietly updated its planetary protection and astrobiology policy, outlining ethical frameworks for first contact, even if it's microbial. The SETI Post-Detection Task Group, led by the International Academy of Astronautics, has protocols for handling the discovery of an extraterrestrial signal: verification, transparency, and global coordination. Because when that moment comes, it will belong to all of humanity. In a way, though, we've already been preparing for centuries. Every time we look at the sky, every time we launch a spacecraft or aim a telescope, we are declaring something profound: that curiosity is stronger than fear, that the human story is not limited to one world. In 2025, as the James Webb Space Telescope continues its surveys, the Roman Space Telescope nears completion, and Plato prepares for launch, the next decade promises an avalanche of discoveries. We may soon have not just dozens, but hundreds of Earth-like planets identified in the habitable zones of their stars. Spectra showing ozone, methane, carbon dioxide, and perhaps even complex organic molecules will follow. Each new finding will tighten the net of possibility until the conclusion becomes inevitable. Life, in some form, exists elsewhere. When that happens, humanity will face a new dawn. We will no longer see ourselves as the center of the universe, but as part of its vast community, a member of something ancient and ongoing. The stars will no longer seem distant. They will be neighborhoods waiting to be explored. And with that realization will come responsibility. Because if life is common, then survival is sacred. Perhaps the greatest discovery won't be out there, but here, realizing that our fragile blue world is one of countless others, and that preserving it is part of a much larger cosmic story. The search for exoplanets is, in truth, the search for meaning. It is a reminder that existence is rare, precious, and fleeting, but also shared. In the end, whether we find life tomorrow or in 1,000 years, one truth already shines through. We are no longer alone in our imagination. The universe has opened its door a crack, and through it, we glimpse infinity, not empty, but alive. And maybe, just maybe, somewhere on a world circling another sun, someone is looking up at their sky tonight, wondering the same thing we are.